sometimes in mathematics, you'll find these situations which are like really weird, because just saying it is weird, but like you'll find these situations which on one hand make absolutely no sense whatsoever. Like maybe you don't know what I mean by this, but I'll elaborate further later. But you have like a situation which on one hand makes absolutely no sense, but on the other hand, if you look at it through like a mathematical context, or like a mathematical through a mathematical scope, and like with respect to mathematical rules, you would be able to say that, okay, well, on the other hand, this situation makes absolutely perfect sense. And so that's kind of absurd just to say in and of itself. I mean, you can't really have a situation which makes absolutely no sense and also makes perfect sense at the same time. And so this is kind of like getting into a philosophical question, but I'm not going to get into that. But what I mean is that you'll have these situations encountered a lot in mathematics. And one place that you'll find this kind of situation a lot in is in a certain subdomain of mathematics, which is called calculus, which is kind of like a topic of study in math. And so I'll give you an analogy of what I mean by the kind of absurdity that you could find in calculus. So here's the analogy. Suppose that this is you over here. So you're just standing over here and you're just chilling. You're just standing for no apparent reason. And you have really long legs for some reason, I guess. Good for you. So you're just standing there. And so separated to you by a certain distance is a wall. You have this wall over here, and it's just over here. Excellent. Okay, well, what about the wall? Well, it turns out that there's something on the other side of this wall that is really interesting to you, and so you want to get to that wall and perhaps even cross it. Okay, excellent. The problem is that there's actually a certain distance separating you and the wall. So, okay, that's kind of a problem. I need to get to the wall, but there's a distance separating me. So how do I get there? You can walk there, or you can run there, or you can swim there, or you could fly there, whatever. You can basically get to the wall by certain methods, I guess. But you decide that you're going to have a little bit of fun, and what you're going to do is you're going to actually take your distance, and since you have nice long legs, which is great, you're going to be able to take a long step and basically jump to take a long step to half of the distance. You decide to do that just arbitrarily for fun. You're like, okay, I'm going to take a big long step over here, and I'm going to take half of the distance. Excellent. Cool. So now you're over here at half of the distance. So you're basically, anyway. So basically you have this distance covered. Now you're like, okay, well, that was great. And it looks like I have less of a distance to cover. Why don't I just do the same thing again? So I'll just go to the half of the remaining distance again. So I'll just go over here. So now you just take a less bigger step over here to half of this distance, basically. Now you're like, okay, excellent. Now I'm over here. I'm getting somewhere. Why don't I just do that again? So now you're gonna take your remaining distance and you're gonna jump to the half of that again, and now you would be over here somewhere. That's great. Well, it looks like we're getting somewhere, and that you're eventually gonna get to the wall, which is really exciting for you. But unfortunately, it's really sad that you won't actually get to the wall ever. And why is that? Well, it kind of makes sense actually. I mean, if you take your remaining distance and you just jump to the half of that, and then you jump to the half of that remaining distance, and then you jump to that half, then you jump half of that remaining distance. Well, you're just gonna be able to keep jumping a certain distance, and you're basically taking your distance, dividing it by 2, then you're taking that and dividing it by 2, then you're taking this remaining distance and dividing that by 2, etc. But this is never going to be equal to 0. Your remaining distance is never going to really get to 0. That's just mathematically impossible. And so this, unfortunately, means that you'll never be able to get to your wall. But in real life, if you were to do this, you would actually get to the wall eventually. I mean, we've all walked to a certain place before. I mean, we know that we can cross certain distances physically, and so that's actually kind of, probably shouldn't be talking about this because this is kind of like a philosophical question. But anyway, so basically what I'm trying to say is that if we were in a mathematically perfect world, for example, what you could say about this situation is that unfortunately you would never be able to get to the wall if you actually kept repeating this behavior. But what we could say is that even though we know that you can't really get to the wall, what we can say is that your behavior is showing that you're getting really, really close to the wall. Actually, you're getting infinitely close to the wall. You're getting infinitesimally close to the wall. That's like a better term to use in the situation. And so you could say that like the limit as you're going to this point over here, the wall, it's like as you're taking half of these steps, you're like basically approaching the wall, but you're never actually getting there. This is kind of an introduction to the concept of the limit in calculus, because and if we're talking in more mathematical terms, a limit is kind of like looking at the behavior of a function at a certain place, even if the function doesn't really exist there. And so I'll draw you a function to give you an example. Suppose that you have this function over here, and this is kind of like a fun little function. And I'm sure if you've taken, I don't know, pre-calculus or whatever, I don't know what classes you can take, secondary 5 math, I don't know. You basically know that this function is y is equal to 1 over x, or it kind of looks like well, actually no, I don't think this is it. No, this is wrong. But anyway, this is actually y is equal to minus 1 over x, right? And so basically, let's look at what happens to your function as you're going to 0. As x is kind of going to 0, and this is the x-axis and this is the y-axis, and you can kind of look at what's happening to your function as your x values are kind of like going to 0. And so for example, if I actually look at it from this side first, what's happening here as my x values are going to 0? Well, you can see that the value of your function, or the height of your function, is kind of like dropping down to, it's like really dropping down really low. But this function actually doesn't exist at y is equal to at x is equal to 0, because if x is equal to 0, this would be 1 over 0, which is undefined. So this is undefined, and so this basically means that the function literally doesn't exist at x is equal to 0. But the concept of limits in math permits us to look at what happens to the function as x goes to 0. And so if we look at what happens to what happens to the function as x goes to 0 from the right, for example, that's a certain way to say it, from the right in this situation. So this is the right, basically. What's happening to the height of the function, or the value of the function? It's kind of dropping down to negative infinity, right? And so you would say in mathematical terms that the limit, this can be new, what do you call it, notation for you if you haven't ever seen this before, but you basically write lim for limit, and then you write x underneath it, or any variable actually, x in this situation, an arrow to say that it's going to something, and I'm going to say that it's going to 0, and I'm going to put a little positive sign on like as like kind of like an exponent, kind of, to say that it's like we're approaching x is equal to 0, but from the right. That's what this positive sign means here. And so I have this function over here, y, or I can even say f of x. And so what's happening to this? Well, this is basically going to negative infinity. That's basically what this means over here. That as my x is going to 0 from the right, my function's value is going to negative infinity. But f of 0 literally is undefined, so you can't really say anything about that. And so in the other sense, you can actually also say that the limit as x goes to 0, but this time I'm going to put a negative sign as the exponent for the 0, which means that x is going to be approaching 0 from the left. That's what this negative sign means. So if x were to approach 0 from this side, what's happening to f of x? Well, it's kind of like it's kind of like going to positive infinity, but it's not actually going to be equal to anything, but it's just going to positive infinity. So we say that this limit is equal to positive infinity. And so there you go. That's basically like introducing to you what a limit is. And so this kind of goes back to like a really philosophical question in math about like, I mean it's actually really crazy if you think about it, because you can actually physically cross distances, but like mathematically, like you can infinitesimally get closer to a certain distance, like to a certain point, and never actually reach that point. If you like take, for example, that we did in this situation, we basically like jumped half the distance, and then half that distance, and then half that distance. So you're never actually getting somewhere, but your behavior says that you are getting somewhere. So that's kind of what I meant by sometimes something can make sense and not really make sense at the same time.